Graph each inequality. You will notice that this inequality is a quadratic inequality. Its corresponding equation would be y equals x squared minus 3x minus 4. The graph of the equation would be a parabola. The graph of this inequality will be a whole shaded region with a boundary that's a parabola. Let's start by graphing this equation. We should know a few things about the graph of this equation just by looking at this equation. For instance, we should know that it's a parabola, and this parabola will open up because the coefficient of x squared is positive. We should also know that the y-intercept would be negative 4, because when x equals 0, the y would equal negative 4. Now, let's find the x-intercepts of the parabola. In order to find the x-intercepts of the parabola, we want to find the values of x that make the y 0. Let's see if we can factor this. This would factor into x minus 4 times x plus 1. Because if we multiply these two binomials together, we would get x squared plus 1x from the outside minus 4x from the inside terms, which would combine to give us minus 3x, and minus 4 times 1 is minus 4. So, that means that either x minus 4 equals 0, or x plus 1 equals 0, which means x equals positive 4, or x equals negative 1. So our x-intercepts are positive 4, 0, and negative 1, 0. Now, to graph the rest of the parabola, I'm going to make myself a table of values. You can do this by hand by just picking some values of x and plugging them into the equation, or you could use your graphing calculator to expedite the process of making a table of values. The table of values would look something like this. Negative 2, 6, negative 1, 0, 0, negative 4, 1, negative 6, 2, negative 6, 3, negative 4, 4, 0, and so on. So let's plot these points. So let's see here, 1, negative 6 is here, 2, negative 6 is here, 3, negative 4, 4, 0, and the next point would also be 5, 6. 5, 6 would be here. So we can see that this is a parabola, and the vertex would be somewhere between x equals 1 and x equals 2. Now, but before I just haphazardly start connecting these points, let's recall that the boundary in this case should be dotted. Just like when we graphed linear equations, if this is a strict inequality, that means the points on the boundary will not make the inequality true, and therefore our boundary should be dotted. Instead of a dotted line, a dotted parabola. Now, let's determine where to shade, either inside of the parabola or outside of the parabola. To do that, I'm going to pick the coordinates of a point, any point really, and I'll use the origin since the arithmetic will be easy. If we take 0, 0 and substitute for 0, the 0 for x and y in this inequality, we'll get 0 on the left and negative 4 on the right. Now we should ask ourselves, is this a true statement? Is 0 less than negative 4? And in fact it's not, because 0 is greater than a positive number. So that means this point that we tested does not make the inequality true. So we need to shade on the other side of the boundary, which would be outside of the parabola. So, the graph of our inequality is an entire shaded region, and it's all of the points outside of this parabola. Now, let's take a look at 1b. Why don't you go ahead and pause the video and give it a try yourself. So, I hope you've given this a try. Let's start by plotting the parabola that would come from the corresponding equation. We should know that the parabola will open down and then its x-intercept will be the origin. I'm sorry, the y-intercept will be the origin, although that will of course be an x-intercept as well. The y-intercept is 0 because when x equals 0, the y would be 0. Now let's see if we can find any other x-intercepts. To do this, we want to find any values of x that make the y equal to 0. Now, to factor this equation, I'll factor out the greatest common factor of these two terms, which would be negative 2x. Negative 2x times x would be negative 2x squared, and negative 2x times a positive 3 would be negative 6x. So this means that either negative 2x equals 0, or x plus 3 equals 0. So that means that x equals 0, or x equals negative 3. Now, we already knew that x equals 0 is one of the x-intercepts. We now know that x also equals negative 3. So here we have the two x-intercepts, and we know that our parabola is going to open down. Go ahead and make a table of values if you haven't already. I'm going to pull up my graphing calculator and do that myself. So, my table of values looks something like this. Negative 4, negative 8, negative 3, 0, negative 2, 4, negative 1, 4, 0, 0, 1, negative 8. So, negative 4, negative 8 would be here. Negative 3, 0 we have already. Negative 2, 4 would be here. Negative 1, 4 is here. 0, 0 we have already, and 1, negative 8 would be here. Now, this time our inequality is not a strict one. We have y is greater than or equal to negative 2x squared minus 6x, which means all of the points on the parabola make the inequality true, so that means the border should be a solid parabola. Now, let's determine which part of the graph to shade, either inside of the parabola or outside of the parabola. Now here we have a sort of unique, interesting situation. We can't test the origin because the origin is actually on the boundary, so we need to pick the coordinates of some other point. You can pick the coordinates of any point that you want, as long as it's not on the border, so I would choose to pick a point where the arithmetic will be as easy as possible. For instance, I'm going to use 1, 1. If y is 1 and x is 1, let's see if this inequality is true. On the left side we get 1. On the right side we get negative 2 minus 6, which would be negative 8. Now, 1 is indeed greater than or equal to negative 8, which means we have to shade the part of the graph that includes this point, which, once again, is the region outside of the parabola. So, in order to graph quadratic inequalities, start by graphing the corresponding equations using your skills of graphing parabolas. Then, as whenever graphing an inequality, determine whether or not the boundary should be solid or dotted. And then finally, pick a point to test to see where to shade.